Okay, hello everyone in a new video. So in this one we are going to explain chapter 4, which is the chapter of resistors, and the second unit of electricity. Basically, any board or electric circuit consists of three main components, and they are given by the resistor, the capacitor, and the coil. So in this chapter we are going to discuss the resistor. Okay, so here in this figure, these electric components are the resistor. So this is the resistor. And as you can see that the resistor is connected to this board. It has two terminals. These are the terminals of the resistor. Then in this chapter we are going to discuss the properties of a resistor. In other sense, we are going to discuss the electric voltage and the electric current across a resistor and to see whether they are related to each other or no. Then let's start by section number 1, the resistor. Idea number 1. So here in this figure on the right, we have the resistor. These are the two terminals of the resistor. Then here in this case, we'll apply the same trick that we have done in chapter number 3, which is giving a symbol for this electric components. So let's give the resistor the following symbol. So it's a rectangle having two terminals. These are the terminals of the resistor, and the letter R stands for resistor. Now idea number 2. Then what's the reason behind the invention of the resistor? Let's consider the following problem. Suppose that we have a battery and the voltage of the battery is given by, for example, 24 or let's say 12 volts. And to this battery, we connect a lamp directly to the battery. And this lamp carries the following indication, which is given by 0.5 amperes. Now, because this circuit is a closed circuit, then the battery will deliver electricity to the lamp L. Then an electric current will traverse the circuit. Suppose that the value of electric current in this case is given by 0.75 amperes. Now, first of all, what does this indication mean? This is the lamp L. So this indication is the rated current of the lamp L under which it functions normally. Then if the traverse current is greater than 0.5 amperes, the lamp will burn out. And if the current is less than 0.5 ampere, the lamp will not function or function weakly. So in this case, the traverse current is given by 0.75 amperes, which is greater than the rated current 0.5 amperes. Then the lamp L will function strongly or burn out. So here there is a probability that the lamp will burn out. In order to avoid this, we have two solutions. Either we replace the battery by another one having a voltage less than 12 volt, which will decrease the value of the electric current, or we replace another lamp such that it has a rated current equal to the traverse current, which is given by 0.75 amperes. But in both cases, these solutions are commercially expensive. So if we want to buy the battery is expensive, or if we want to buy the lamp is also expensive. So what they have done, they have invented the resistor. So the resistor, what's the role of the resistor? The resistor is an electric component that is used to protect other electric components by limiting the flow of electric current. Then here, if you connect to the lamp a resistor like this, then now this electric circuit consists of three electric components: the battery, the lamp, and the resistor. Now, because we have added a resistor in series with the lamp, so this current will decrease, say for example to 0.5 amperes, and this is the role of the resistor, because the resistor is an electric component that is used to protect other electric components by limiting the flow of electric current. And because now the electric current, which is given by 0.5 amperes, which is the traverse current, is equal to the rated current, then the lamp L will function normally. So the role, I repeat, the role of the resistor is an electric component that is used to protect other electric components by limiting the flow of electric current. So here we can say that this is the role of the resistor. Not only this, but also the resistor is an electric component that transforms electric energy into thermal energy. Then the resistor is an electric component that transforms electric energy into thermal energy, and by thermal energy I mean the heat energy. So all electric appliances that gives heat, for example the electric heater or the iron, consist of a resistor. So the resistor is an electric component that transforms electric energy into thermal energy. So this is the second role of the resistor, or other role of the resistor. Then the resistor has two roles: either to protect other electric components by limiting the flow of electric current, and here by limiting I mean that the electric current decreases. Then this is the first role, and the other role is that it transforms electric energy into thermal energy. Now, what distinguishes one resistor from the other? Let's say that each resistor is characterized by its own resistance, denoted by R, where the SI unit of R is ohms, and its symbol is omega. Then each resistor is characterized by its own resistance. For example, we may have that a given resistance is of 20 ohms, or R is equal to 30 ohms. Then each resistor is characterized by its own resistance. And now let's move to the next section, which is Ohm's law. Now section number 2, Ohm's law. Ohm's law states the relation between the voltage and the current across a resistor. Now suppose here we have the following resistor having a resistance R. These are the two terminals of the resistor. Now suppose that we apply to this resistor a voltage given by U, and it's being traversed by an electric current I. Now here I'm supposing that this resistor is connected to a closed circuit. Now we can ask the following question: what's the relation between U, I and R? And this is given by Ohm's law. Ohm's law is given by that the voltage U is equal to the resistance R multiplied by the electric current I. And recall that always in physics we need to mention the law that we are using. This law is given by Ohm's law. Therefore let's say apply Ohm's law. We are applying Ohm's law to the resistor R. So let's say that the name of the resistor is given by R. Now what does each quantity represent? Where U is the applied voltage, or let's say the voltage across the resistor, and we know that the symbol of the unit of voltages is capital V, which stands for volts, and I is the current across the resistor. Now the symbol of the unit of the electric current is capital A, which stands for amperes, and R stands for the resistance of the resistor. R is the resistance of the resistor. Its unit is denoted by omega, and the name of the unit is ohms. Okay. Now for any triplet, or say for any formula like this, we can construct a triangle. Now here, because we have multiplied, then U will be on the top and R and I at the bottom. So say for example that from this formula, if you want to calculate the value of R, then R, if you put our hand over R, so R will be given by U divided by I. Moreover, from this formula we can calculate the value of I if we know U and R. So putting our hand over I will be given by what? U divided by R. Moreover, let me give the following remark. Note: so U at the top and I at the bottom, this is given by Ohm's law. Now notice that here, because U is at the top and R is at the bottom, so we say that U and R are directly proportional, and this is means, what does this mean? When U increases, I increases, and this is because U and R are directly proportional. Now say for example, what about the proportionality or the relation between the quantities U and I? Now notice that U is at the top and I is at the bottom, so U and I live in different floors. This means that they are directly proportional. What is meant by directly proportional? That the relation between them is directly. So when U increases, sorry, here it is R. Okay, when U increases, let me correct it. And in this case, U and I are directly proportional. When U increases, also I increases. Now, what about the quantities R and I? So notice that R and I live in the same floor. So whenever two quantities live in the same floor, we say that they are inversely proportional. And what is meant by inversely proportional is that when R increases, because the relation or the proportionality between them is inversely, then I will decrease. Now let's solve exercise number 1 as a direct application on what we have explained. Now they are telling me consider a resistor R of resistance R is equal to 20 ohm. So the value of the resistance R is given by 20 ohms. This electric circuit consists of a battery. Connected to the battery we have a resistance R. So this circuit is a closed circuit, therefore an electric current will traverse the circuit, and the value of the electric current is given by 0.1 amperes. Okay, I connected across a battery delivering a constant voltage. Knowing that the current in the circuit is I is equal to 0.1 amperes, we need to find the voltage UR across the resistor. And in order to find the voltage UR, so what's the relation that gives me the voltage knowing the electric current and the resistor? This relation is given by Ohm's law. And I repeat, always in physics we need to mention the law that we are using. Then let's say apply Ohm's law. Now here, let's be careful. We are applying Ohm's law. Okay, what are this electric circuit consists of two electric components, the battery and the resistor. And here we need to mention that we are applying Ohm's law to the resistor and not to the battery. So apply Ohm's law to the resistor. The name of the resistor is given by R. And Ohm's law is given by that U is equal to R multiplied by I. Now the value of R is given by 20 and the value of I is given by 0.1. Plugging this on the calculator will give us 2. Since R is in the SI and I is in the SI, so the value of U will be in the SI, which is volts. Then the voltage U, so the voltage is denoted by UR. The voltage UR across the resistor is given by 2 volts. And now in exercise number 2, they are telling me consider the following electric circuit consisting of a battery, an ammeter of negligible resistance, a voltmeter, and a resistor R. The ammeter and the voltmeter display 0.5 amperes and 15 volts. So the indication 0.5 amperes corresponds for the ammeter because we know that the ammeter measures electric current. Then let me write here that the value of the electric current I traversing the circuit is given by 0.5 amperes. And the indication 15 volts is displayed by the voltmeter because the voltmeter measures the voltage. Then this is 15 volts across the resistor because notice that the voltmeter is measuring the voltage across the resistor. Now in number 1 they are telling me calculate the resistance R of the given resistor. Then here in this case we know the voltage across the resistor and we know the electric current traversing the resistor. Then in this case using Ohm's law we can calculate the value of the resistance R across the resistor. Then let's say apply Ohm's law. And here we are applying Ohm's law to the resistor R, to R. And Ohm's law is given by that U is equal to R multiplied by I. Let's construct the triangle of this formula. So U at the top, R and I at the bottom. We are interested in calculating the value of R. Putting our hand over R, R is given by U divided by I. Now the value of U across the resistor is given by 15, and the electric current I traversing the resistor is given by 0.5. Plugging this on the calculator will give me 30. Since U is in the SI and I is in the SI, so the value of R will be in the SI, which is ohms. Then R is equal to 30 ohms. Now in number 2, they are telling me what's the voltage across the ammeter. Notice that here they told me that the ammeter is of negligible resistance. Therefore, the voltage across the ammeter is 0 because it's of negligible resistance. We know this from the previous chapter, chapter 3. We have said that the voltage across the ammeter is 0 because it's of negligible resistance. Now, because we have introduced the notion of resistance or explained what's meant by resistance, now let's explain the following statement. Why? When the resistance is negligible, then the voltage is 0, and this is given by Ohm's law. So, negligible resistance means that the value of the resistance is almost 0. Then here we can replace R by 0. So 0 multiplied by I, anything multiplied by 0 will give us what? 0. Therefore, whenever any electric component is of negligible resistance, the voltage across it will be 0, and this is given by Ohm's law. Now, exercise number 3. They are telling me consider an electric component D acting as an ohmic conductor of resistance 75 ohms. Then R is equal to 75 ohms. Connected through a battery of 25 volts. Number 1. Draw a diagram illustrating the above given. Here, let me explain what is meant by ohmic conductor. Ohmic conductor means that the electric component D can be considered as a resistor. So I repeat that the word ohmic conductor means it can be considered as a resistor. In number 1, they are telling me draw a diagram illustrating the above given. So in the given, they are telling me we have a battery of 25 volts. These are the terminals of the battery. To this battery, we connect an electric component D that can be considered as a resistor. The name of this electric component is D, and the value of its resistance is given by 75 ohms. Now in number 2, they are telling me determine the current in the circuit and indicate its direction on the drawn diagram. Now here we know that the value of the voltage across the battery is given by 25 volts, so the voltage across the electric component D will be also 25 volt. For the following reason, we can say that the electric component D is in parallel with the battery. So according to law of uniqueness of voltages, they have the same voltage, or we can simply prove it using the law of addition of voltages. If you consider that this is the point A, PA, B and N. So PA is 0 and BN is 0 connecting wire. Therefore, UPN will be equal to UAB will be equal to 25 volts. Then what's the law that gives us the electric current knowing the voltage and knowing the resistance? This is given by Ohm's law. Then apply Ohm's law. Now here we have two electric components and they are given by the battery and the electric component D. We must be very careful that we are applying Ohm's law to the electric component D and not the battery. So apply Ohm's law to D. This law is given by that U is equal to R multiplied by I. Let's construct the triangle of the following formula. Then U, R, and I. We are interested in calculating the value of I, putting our hand over I. Then I will be given by U divided by R. The value of U is given by 25. The value of R is given by 75. And this, if we plug this on the calculator, it will give us 0.33. Since U is in the SI and R in the SI, so the value of I will be in the SI, which is given by amperes. Then the value of the electric current is given by 0.33 amperes. In the same part, they are telling me indicate its direction on the drawn diagram. We know that always the direction of the electric current is from the positive pole to the negative pole. And the value of the electric current in this case is given by 0.33 amperes. Now we have reached section 6, which is given by the characteristic, current, voltage, curve of a resistor. Then 5 important things to notice. Now here on the right, here on the right, we have a graph. So the x-axis of this graph is labeled by the current I, the unit of I is milliamps, and the y-axis of this graph is labeled by the voltage U. For this reason, the name of this section is given by characteristic current voltage. Now this is the curve, although it's a straight line, but we name it to be a curve of a resistor. Now 5 important things to notice. Let's start by idea number 1. The characteristic current voltage curve of a resistor is a straight line passing through the origin Notice that here the shape of the curve that's being plotted in the x. In this orthonormal system, say for example, the x-axis is labeled by the current I and the y-axis is labeled by U. Then the shape of the obtained curve in this case is a straight line and it's passing through the origin. This is the origin, which is the point 0. And whenever the shape of the obtained curve is a straight line passing through the origin and it's being plotted in the following system, the x-axis is given by I and the y-axis is given by U, then the nature of this electric component is given by a resistor. Now idea number 2 is that the resistance of the resistor is equal to the slope of the characteristic current voltage curve. Now in In the coming section, I will explain what's meant by idea number 2, that the resistance of the resistor is equal to the slope of the characteristic current voltage curve. Now, idea number 3 is that for a resistor, the ratio U over I is constant, and it is equal to its resistance. So what do we mean by idea number 3? Now here, if we refer to this curve, let's choose the following point to be the point A. Now the point A has a voltage to be 10 volt and have an electric current I to be 20 milliamps. Now if we convert this to the SI, we know that from milliamps to amps we divide by 1000. Now this is equal to 0.02, and this is equal also to 0.04, 0.06, 0.08, and 0.1. Now if for the point A, if we divide 10 by, so now in this case we are calculating the ratio U divided by I for several points. Now for the point A, 10 divided by 0.02, this will give us 500. Now if we choose another point here to be the point B, and we divide the voltage over the current, so 20 divided by 0.04, this will give us 500. Now if we repeat this calculation for all the points on the curve given by C, D, and E, and we can choose as many points as we want, we will notice that this ratio will remain constant, and whenever this ratio is constant, then the electric component is considered to be a resistor, and the ratio U over I in this case will be equal to its resistance. Now idea number 4, for this curve, the voltage, if the voltage across the resistor is 10 volts, then the current is 20 milliamps. So referring to this curve, if we know the voltage across the resistor, referring to the curve, we can determine the value of the electric current traversing this resistor. So if the applied voltage is 10 volt, now 10 volts correspond to this point on the curve that has an electric current of 20 milliamps. So whenever we know the voltage referring to this curve, we can determine graphically the value of the electric current I, and similarly for this curve, in this case, if we know the electric current, if the current say for example is 40 milliamps, so now we know that the electric current across the resistor is given by 40 milliamps. 40 milliamps correspond to this point on the curve that has a voltage of 20 volts. Then we know that the voltage across the resistor is given by 20, then the voltage is 20 volts. And now let's introduce the slope method. So how to determine the slope? We have mentioned previously that the slope is equal to the resistance. Then the slope of this curve is equal to the resistance. If we are able to calculate the slope, then we are able to calculate the resistance. Here in this graph, we have I and U, and we know that U, I, and R are related via Ohm's law. So from this curve we can calculate the value of the resistance R, but not using Ohm's law, however using the slope method. So the first step, step number 1, is to write the definition. And the definition is given by idea number 2, the resistance of the resistor is equal to the slope of the characteristic current voltage curve. Current voltage. Now step number 2 is to choose any 2 points on the curve. And let's choose the following points. So this is the point A and this is the point B. Now what are the coordinates of the point A and B? A has a value of electric current given to be 20 milliamps, and it has a voltage given by 10 volt. As for the point B, it has an electric current given by 60 milliamp and a voltage given by 30 volt. And here always we write first the electric current, then the voltage. Now step number 3, change the units of the chosen points to the SI. So the point A, 20 milliamps, we know that milliamps is not the SI unit of electric current. The SI unit of electric current is given by amperes. In order to convert from milliamps to amps, we need to divide by 1000. Then dividing 20 by 1000, this will give us 0.02 amps. And volts is already in the SI. And the point B, converting it to the SI, 60 milliamps dividing by 1000, it will give us 0.06 amperes. And volts is already in the SI. Now we are ready to calculate the slope using the the resistance using the following formula. Then step number 4, calculate the resistance using the formula given by R is equal to the voltage of the point A minus the voltage of the point B divided by the current of the point A minus the current of the point B. Now let's use the following formula to calculate the resistance of the resistance R. R is equal to UA minus UB divided by the current of the point A minus the current of the point B. Now the voltage of the point A is given by 10 and the voltage of the point B is given by 30, and we can know this from the units. Now the current of the point A is given by 0.02 minus the current of the point B, which is given by 0.06. This will give us minus 20 divided by minus 0.04. Now minus goes out with minus. This will give us 20 divided by 0.04. Plugging this on the calculator will give us 500. And here, because everything in the SI, the unit of R is given by ohms. Then R is equal to 500 ohms. Always the resistance must be a positive quantity. Now, using this method, referring to the curve, we can calculate the resistance of a given resistor. Now, exercise 4 is a direct application on the slope method. They are telling me, given the characteristic current voltage curve of a resistor, calculate its resistance. Now, notice that here the curve is being plotted in the current voltage graph. So on the x-axis we have the current, on the y-axis we have the voltage, and because the shape of the obtained curve is a straight line passing through the origin, we can know that the nature of the electric component is a resistor, and we need to calculate its resistance using the slope method. So step number 1 is writing the definition, and the definition is given by the resistance of a resistor is equal to the slope of the characteristic current voltage curve. And now step number 2 is to choose any 2 points belonging to this curve. Let's choose this to be the point A and this to be the point B, for example. Now, what are the coordinates of the point A and B? A is given by 20 milliamps. I repeat that always we start by writing the current and the voltage, and 1 volt. A, the point A, has a value of electric current 20 milliamps and a voltage given by 1 volt. As for the point B, it has an electric current given by 100 milliamps and a voltage given by 5 volts. Now the next step is to convert these quantities to the SI. From milliamps to amps, we simply divide by 1000. Then A, 0.02 amps and 1 volts. Whereas the point B has the following coordinates, 0.1 and 5 volt. Now we are ready to calculate the resistance of the resistor R, represented by this curve, using the slope method. R is equal to the voltage of the point A minus the voltage of the point B, divided by the current of the point A minus the current of the point B. So the voltage of the point A is given by 1 volt. How do we know this from the unit? So 1 subtracted. So the voltage of the point B is given by 5 volt. So 5 divided by the current of the point A is given by 0.02 minus the current of the point B, which is 0.1. This will give us minus 4 divided by minus 0.08. Minus goes out with minus. This will give us 4 divided by 0.08. Plugging this on the calculator will give us 50, since everything in the SI and the unit of R is given by ohms. So the value of the resistance of the resistor R is given by 50 ohms. Now exercise number 5 in section 8. They are telling me we vary the voltage U across an electric component D between 4 volts and 8 volts, and we measure the corresponding values of I. The results are shown in the following table. Now they are telling me complete the table. So here in the table, the first row we have the value of the voltage U, and in the first row, and in the second row we have the value of the electric current I in amperes. They are telling me to complete the table. The third row consists of the ratio U over I. So let's complete this table. Now dividing U by I, 4 divided by 0.35, plugging this on the calculator will give us 12.43. So here we have 12.43. Now 5 divided by 0.39 will give us 12.82. Sorry, here 11. $12.82. Now 6 divided by 0.43, this will give us 13.95, and 7 divided by 0.46 will give us 15.22, and 8 divided by 0.49 is equal to 16.33. This is it for number 1. Now in number 2 they are telling me the electric component cannot be considered as a resistor. Justify. Now if we refer to this section, in idea number 3 we have mentioned that for a resistor the ratio U over I is constant and it's equal to its resistance. Then we can say when the ratio U over I is not constant, then the electric component cannot be considered as a resistor. Now let's say, since the ratio U over I is not constant, and this is simply because 11.43 is not equal to 12.82, is not equal to 13.95, etc., then D cannot be considered as a resistor. Now in exercise number 6 they are telling me consider the following electric circuit. A generator G of adjustable value, this is important. A resistor R of resistance R is equal to 20 ohm connected directly to G. Number 1, draw a diagram of the above circuit. This is the generator, which is the battery, connected directly to a resistor of name R. So the value of this resistance is given by 20 ohm. Notice that here the generator G, they told me that it is of adjustable value, and this is the symbol of the generator of adjustable value. We simply place an arrow from the positive pole to the negative pole. Now this is the diagram. They are telling me number 2, if UG is equal to 20 volts. I repeat that always the trick in solving such type of exercises is to write the given on the electric circuit itself. So UG is equal to 20 volts. They are telling me to calculate the current I crossing the resistor. And this can be done using Ohm's law. Then apply Ohm's law. Here notice that we are applying Ohm's law to the resistor R and not to the generator G. And Ohm's law is given by that U is equal to Ri, R multiplied by I. Now notice that because R is connected directly to the generator G and the generator is adjusted to 20 volts, then the voltage across the resistor is given by 20 volt. Constructing the triangle of this formula, U at the top, R and I at the bottom, we are interested in calculating the value of I. The value of I is given by U divided by R, which voltage UG. Now the value of UG is given by 20, the value of R is given by 20. So this will give us 1. Since U is in the SI and R in the SI, so the value of I will be the SI, which is given by amperes. Then the value of the electric current I traversing the resistance is given by 1 ampere. So that's it for me in this video, guys. And the next one will complete the explanation of this chapter.